So I'm Ben Klang. I'm from Mojolingo, based in Atlanta. We build voice applications. And this lovely lady really does not need much introduction, only to hear her voice, and I think you would recognize her.
Absolutely. Hello.
Pretty readily.
Yes.
Allison Smith, the voice of Asterisk. In today's presentation, though, this talk being using Asterisk to build her, Allison has agreed to play the part of her as we build this virtual assistant. So, a little background. Very quickly, I mean, how many of you have seen the movie Her? Just quick show of hands. A handful? Okay. At least know the concept, maybe? A bunch more? Okay. Very quickly, the movie Her is all about an artificial assistant. Basically, they call it an artificial operating system, which is maybe a bit of a stretch, but we'll go with it. And the idea is that it lives sort of in his phone. It gives him the ability to interact with the world, to answer questions, to handle minor tasks. What's really particularly interesting about this movie is that he really only interacts with her audibly. Now, she has a personality, obviously. It's why we call her Her. And she has a name. But you never see her. You really only interact audibly. You see him ask her questions, and you hear her answer him. So in the movie, this artificial intelligence is called Samantha. But of course, we have Allison. What we also have is Asterisk. And so what the talk today is about is how you might go about building something that sort of resembles her in Asterisk. So how might this work? We have access to some of the core technology required to make this happen. We have automatic speech recognition. We have natural language understanding. Text-to-speech, obviously very critical. We have lots and lots of APIs for looking up information, for feeding data back. But it's really not just about the technology. It's got to be useful to a human being, and it has to be usable. So let's start by talking about her personality. If we're going to create a new personality to be our virtual assistant, we have a lot of options. What kind of assistant is she? How does she behave? Maybe she has a straight, sort of no-nonsense personality.
Hi, Ben. I'm Allison. How can I help you?
All right, but that's a little boring. Kind of sounds like a IVR for my bank, maybe. But she could be maybe bubbly or friendly.
Hi, Ben. It's Allison. How can I help you?
Could be sassy or smart-mouthed.
Well. Oh, did we miss one? Oh, no, that's fine. Hi, Ben. It's Allison. How can I help you?
She could be relaxed or laid back.
Hi, Ben. It's Allison. How can I help you?
Could be energetic and excited.
Hi, Ben. It's Allison. How can I help you?
Whoa. Or maybe sultry and provocative.
Well, hi there, Ben. It's Allison. How can I help you?
So since we're creating a virtual assistant for the rest of our talk, I would put it to you, the audience, which of these should we have for our virtual assistant? Anyone have an opinion? What? Anyone? No? Sultry?
Yeah.
Sultry it is.
We kind of knew it was going to go that way.
So this is important, though. This is why personality matters. Allison, I'm really thinking about the future. And I'm thinking I want to look into some coffins, what I might be buried in. Maybe you can give me some advice, some research on that.
Well, sure. I'm here to help you pick out your next coffin. What do you think of pink?
So clearly, sultry personality doesn't mix particularly well with thinking of our final disposition. So think about your audience, think about what they're trying to do. Keep in mind that the personality you choose will reflect your organization. It needs to be compatible with the brand that you've established. The personality you choose will guide how your users interact with the virtual assistant. It's very important. Okay, so back to a little bit of technology. How does she work? First, we'll start with the input and output, right? So my questions come in the form of voice. The next phase is to take that voice and to recognize it. So this will be just simply taking the speech and turning it into a text representation that a computer can process. Once we have that text, we'll turn it into, we'll pass it through some natural language understanding. This is what will actually allow the software to handle the request. It's the intelligence part, it's the understanding. Then we'll send whatever we've understood the intent of the user to be, whatever the question is, we'll run that through a researching phase. We'll hit up whatever APIs, databases, Whatever sources of information can be brought to bear to solve or to answer that question. And then, of course, we have to respond. So there's going to be a text-to-speech component, and then that goes back out to the input-output channel. So it's a circle. Just keep doing that over and over. Let's start with the first phase. We'll go with recognizing. So there are several different types of ASR, 4 in particular that are important. The most common one people think of when they think of speech recognition is dictation or transcription. So when you have Google Voice and you get your voicemail and you get a transcription of that voicemail, that would be transcription. However, transcription, especially in a telephone network, doesn't always work too well because of low-quality audio. So a lot of the time, you'll have a grammar-based recognizer. So this is the kind of thing where you talk to the bank, and the bank asks you a very specific question, and you give it a very specific response. Hotword detection, so that is looking at a stream of audio and listening for a certain word. So a great example of this would be like Google Glass, where you put the glasses on and you say, "Okay, glass," and it wakes up the glasses. Another one is good is biometrics or identity. So if you want to authenticate someone by using their voice as my voice is my passport, verify me, that would be biometrics. And while ASR is very important, I also want to make a note that DTMF has its place. There may be times when a user who's on a telephone doesn't want to speak. So for example, if you're passing sensitive information like a social security number. Now obviously on a telephone call, our alternative to speech is DTMF. If we look beyond the telephone, other inputs might be a web form. My point here is don't necessarily force the user into voice. And then there are a couple ways to get ASR connected to Asterisk. There are 2 types of media connections, MRCP and HTTP. We'll go very quickly into these interfaces. So MRCP, Media Resource Control Protocol, is the standard way for connecting real-time streaming audio from a telephone system to some kind of speech recognition engine. Because it's because it's an audio stream, it'll have the quickest response time. It will feel the most reactive, because as soon as it detects something that it recognizes, it can immediately send a signal back. MRCP v2 also happens to be SIP-based. It's very similar to SIP. You can actually use some of the same tools you're familiar with, like Chameleon, to load balance MRCP connections. The downside, though, is it's somewhat more complex than an HTTP API, especially if you are not a telephony person. If you're a web developer wanting to do speech, MRCP is going to be like trying to teach a web developer SIP. It's just not easy. So it's not very friendly to mobile apps. The alternative would be something like an HTTP API. Obviously very mobile friendly. All mobile developers seem to love a little HTTP. That's a very simple API. You basically post some parameters, you get a response. That's great. But because you're often doing a record, upload, get the response kind of turnaround, the latency on that is more noticeable. And I mean actually noticeable. You might think that 50 milliseconds, 100 milliseconds, 200 milliseconds might not matter, but it really does. Especially if you have to wait for silence and then send it off. You're adding perhaps a full second of silence detection before you send it to the API. That can make it really feel kind of awkward. Now, there are several vendors that work with Asterisk. I did a quick matrix. This does not begin to fully express all of the intricacies of dealing with speech vendors, but I wanted to at least recognize that there are several opportunities. A couple of them are, the top 3 are really more traditional telephony, MRCP type interfaces. The bottom 2 are more HTTP. And I need to single out Google, only because I get asked about it all the time. People want to use Google's speech recognition because it's very good. The problem is you can't buy it. And because you can't buy it, it's not really a service. And so that API could change tomorrow. So I can never actually recommend people actually go build a business on this because you're just waiting to be broke. But these other vendors are more stable, more predictable. They offer good services. All right, so that's all about speech recognition. Let's go to understanding. Earlier, I kind of hinted at grammar-based recognition. I want to give an example. I think you'll all find this very familiar. So I'm going to invoke Allison here. And Allison?
What can I help you with?
I'd like to book a flight.
Where are you flying from?
Atlanta.
Where would you like to go?
Chicago.
Tell me the month and day you want to leave.
August 5th.
Tell me the month and day you want to return.
August 8th. Okay, that's really obnoxious. that is not a good user experience. I'm spending a lot more time just trying to, complete my request. So now let's look at it in the form of something like a natural language request. Allison, I want to go to AstriCon. It's in Las Vegas. I'm going to leave October 1st, be gone for about 3 days, and I want the last flight out.
Okay, Ben. I understand you want to leave Atlanta for Las Vegas on October 21st, returning October 24th. And you also want the early flight home. Do I have that right, Ben?
That's correct. Thanks, Allison. So what we've done here is she's able to parse out the pieces of the sentence, regardless of how I specifically ask it. I could have changed the wording. You notice that I didn't use a specific day here, but she was able to calculate an offset from the beginning. Also, I never said where I was coming from, but she knows me, she knows where I am, she's able to infer that. And then, of course, by confirming it through me, just in case I happen to be somewhere else, I can change that. But this is a much easier interaction, and this kind of technology is possible with NLU. All right, so we've done the understanding part. Let's move on to researching. So the kind of typical thing you get, if you look at something like Siri or Cortana, you can ask Allison, send a tweet. Hey, tweet me for AstriCon.
Tweet coming at you right now, Ben.
Thanks. Or Facebook, I'm checked in. Oh, check me in at AstriCon.
Ben, you're all checked in.
Thanks. I could ask about the sports scores, but I gotta admit, I'm not really a sports fan. Get a table at a restaurant or check the weather, but this has all kind of been done, right? And this is very generic. It doesn't really know a whole lot about the end user. So to me, this is really kind of boring. Where I think we can create, we as an industry and we as developers building these applications, where I think we can create value is inside an organization or inside some specific user base where we know the context, what the user needs to do, what they have done. So let's imagine that I'm going to create an Allison that knows my company, knows my processes, and I can ask her things like, how many sales reps are still out in homes right now? Or how much have we sold so far this month? Or how many callers are waiting in the queue? Or, hey, I'm on a call, can you add my manager to this call? And again, knowing that who I am, I can look in the org chart and know who my manager is. Or when is my next appointment slot? So Allison, what are our sales figures for this month?
Well, Ben, I'm happy to report approximately $57,000 in widget sales, which is up 12% from this time last month.
That's a good month. Hey, would you send that to my boss and get him on the phone for me?
His line is busy at the moment, but I've sent the message to him via instant message. I'll connect you as soon as I can, as soon as he's off the phone.
Awesome. So a lot of context is brought to bear. She knows who my boss is. She knows his telephone extension. She can see his phone is engaged. She can communicate over multiple channels. That message was sent to him via instant message. And of course, when he does hang up, then I get the connection via voice. So that's pretty cool. And all of that is possible because she doesn't just know who I am, but she knows who I am within the context of my job and the other information systems available to her, through the sales tracker, CRM, whatever that might be. So we've gone through most of these things. We're on the output side, the text-to-speech side. So one thing, and I kind of hinted at this at the beginning, but choose your voice carefully. And I say that not just in terms of choosing the personality, but the quality of voice databases varies quite widely. A lot of people might try to launch something using an open source text-to-speech engine like Festival or Flight. And they're functional, but in no way are they great. They just don't sound very good. A lot of what you're paying for when you purchase commercial text-to-speech engines is that larger voice database and the improvements in their intonation, in the flow of conversation, recognizing punctuation. So it's really important to evaluate those. And then the tone of the voice imparts almost as much as the content. You can really misinterpret something just by sort of inferring it or saying it with a bad tone. And one thing I always recommend is for best possible user experience, where you can, mix your text-to-speech with pre-recorded audio. Any good text-to-speech server will do this actually for you. So when you flow things, when you flow messages back to the user, you'll have the things that are pre-recorded where the standard parts like I'm going to confirm your reservation, but then you text-to-speech the name, right? Or you text-to-speech whatever the variables are that you can't easily pre-record. And the good engines will make that without any gap in playback. So it has a much more natural sound, and the human ear can follow it, because all of that intonation that a text-to-speech engine can't get just right, a human certainly can. And of course, consider the context of the user. Check things like prosody, which is the rate, the pitch, the volume. You probably have picked up that I talk pretty fast. My grandmother probably doesn't talk as fast as I do. So think about who you're talking to, and you might slow down the tone just to make sure they can kind of keep up with everything you have to say. The other thing I recommend is structure the answers to questions similar to the question itself, or vice versa. Structure the questions in the format you want the answer. The format of the question will help guide the user, lead the user to the kind of input you're looking for, and will direct the response. It just helps the user experience. And when you know what to, your brain is very good at matching things it expects. So if you set up the expectation for the user for how you want to interact, then when you give them the answer, they're able to follow along that much more easily. And always give an option to repeat. Because sometimes I didn't hear, sometimes a tree fell down next door, or a chainsaw started, or who knows what, right? And then a lot of these things, I'm not going to go into SSML, but there is a markup for text-to-speech that allows you to control a lot of these outputs, to control the rate, to control the pitch. If there's a particular response that I want to have elevated, some kind of warning, I can use SSML to punch that up. Okay, so we've kind of gone full circle here. And I wanted to bring up one other important thing, and that is that the telephone is not the only way we interact anymore. It used to be that the primary interface was the telephone, but with things like WebRTC, with smartphones, we might use telephone protocols to carry audio. That doesn't mean it's going to be the context of a telephone call. And so we can do things that combine multiple channels. We can go beyond just voice. We can also have a visual interface component to go with it. So multimodal apps, you can request the information by voice, but then you can receive that information by another channel, maybe by some kind of screen, a text message, web browsers. WebRTC, I think, is going to be huge here. The ability to dynamically draw to a screen animations or links or to push information and have audio go with that, I think is tremendous. And it also gives you the opportunity to allow input to be controlled from multiple sources. So I might start an interaction with a click, because that's the most natural thing. If I'm on a web page, a click is kind of a natural interaction. But then there may be a case where I want to switch to voice. Actually, in Mac, there's a speech recognition engine built in. And a lot of times, because I'm a developer, I type all day long and my wrists get tired. So I'll actually use text-to-speech to dictate emails. So I'm still clicking to actually start the email or move things around. But when I want to type, I'll invoke the recognizer. And that kind of mixed interaction is really pretty powerful. Allison, I'm looking for a picture from the last AstriCon. When we took Randy out to dinner, I don't remember exactly when it was, but could you find it for me?
I found one picture that includes you and Randy Resnick, one evening in October of last year. I've sent it to your screen.
Oh, sweet. I found the wrong pocket. Prairie Pops. Okay, so there you go. So I'm able to ask the question. She can send me something by another channel. That's really powerful. So that's what we have to talk about. And by the way, Allison would love to be the next series. So any of you who can help her realize that goal.
Yeah.
And would love to answer any questions you have.
Any questions?
Oh, yeah. Okay, thank you.
Ben, what kind of ASR engine do you find the best?
There's not a simple answer to that question. There are a lot of factors. Cost is certainly one factor, but it's not the only one. These days, most engines have pretty good compatibility. A few years ago, I would have told you that you had to be careful because some of them implemented the specs differently and it just wouldn't work. Today, that's less of an issue. More importantly, though, is language. Not all speech recognition vendors support all languages. Well, they don't all support all languages. Some have broader support. Certainly, all the ones that I showed you on the screen support US English. Not all of them support, say, France French versus Canadian French, or Mexican Spanish versus Spain Spanish, which are pretty different. And then the more far afield you go, into African languages, Asian languages, the coverage is more spotty, so it even becomes more of a factor. So, and there are also other technical things which are harder to quantify, like noise rejection. Some speech engines work better with a noisy background, say a motorcycle helmet going down the highway. Others work better in a quiet environment. And then again, there's also transcription versus grammar-based. Not all of them support transcription. So I can't give you a very direct answer, but if we could talk about your app maybe after this, we can see what might work for you.
Thank you.
Any other questions? I'll just moderate. I'll just take over the whole thing. Questions?
Anyone want to ask Allison anything? I mean, she can answer all kinds of questions.
No? No questions? No?
No questions?
Mysterious. Oh, here's one right over here. All right.
So how did you get Allison to actually answer the question that you ask?
So if you look right here behind her head, there's a little microchip that we implanted. It's wired up to my laptop.
Because most of the time when I ask, when it tries to recognize me, I'm a little bit too Southern.
Okay.
And I get an answer for something that I didn't ask.
Right. Yeah. There is not a U.S. Georgian database. I wish there were. It's tough. I mean, again, that's going to vary a little bit by vendor. There's not an easy answer to that. You can play with confidence levels. So if you have a user base that has particular confidence, you can that's having a hard time being recognized, you can try dropping the confidence. And you will get a confidence score in the response, so you can often use that. If the score is high, you just move on. You probably understood the intent. If the score is low, then you can reprompt. I think I heard you say, whatever. And do that intelligently, because people don't like getting asked over and over.
If it's any consolation, I ordered flowers for a client, and it was me on the IVR, and I kept telling me, I'm sorry, I don't quite understand you. And it's like, what, are you kidding me? I'm you. You're me. Why? Yeah. So it's not an accent thing necessarily. Yeah.
The other thing I'll add, if you have sufficient time and budget, a development budget, is you can create custom grammars. It's a lot of work, but you can actually tell the recognizer what to expect, and there is a phonetic alphabet you can use to hint what it's looking for. But it's a development effort associated with that.
Any other questions?
Is everyone just really hungry? Allison, what's for lunch?
Unsure.
I don't know either. I was surprised it was barbecue yesterday.
No?
No? Okay. Well, thank you all for coming. Enjoy lunch.
Thanks very much.